Hello friends, myself R.D. Mazen presenting my video on Z transform. Let us find Z transform of 1 by 3 whole raised to mod of n for all values of n. And as it is required for all values, Z transform of that f of n is given by summation from n is equal to minus infinity to plus infinity f of n into z raised to minus n. Then splitting it, n is equal to minus infinity to minus 1 f of n into z raised to minus n plus summation of from n equal to 0 to n is equal to infinity f of n into z raised to minus n. We know that absolute value of n, there are two values for absolute value. It is minus n for n less than 0, negative values. The absolute value of n is minus n, and absolute value of n is plus n for n greater than or equal to 0. And therefore, using this information, this is as per the definition of mod of n. This equation becomes, therefore, Z transform of that 1 by 3 absolute value of n is equal to summation from n is equal to minus infinity to minus 1 f of n. F of n, it becomes 1 by 3 raised to mod n, and value of that mod n is minus n. Therefore, it is minus n into z raised to minus n, and plus summation from n equal to 0 to infinity f of n is 1 by 3, and when it is greater than or equal to 0, the value of mod n is n, and therefore it is 1 by 3 raised to n into z raised to minus n, and we call this as equation 1. Then we try to find out z transform of the first term and z transform of second term separately, and therefore z transform of first term is summation from n is equal to minus infinity to minus 1 by 3 raised to minus n and z raised to minus n. Here we substitute n is equal to minus r. When n is minus infinity, we get minus infinity is equal to minus r, means r is equal to infinity, and for n is equal to minus 1, we get minus 1 is equal to minus r, means r is equal to 1. Using this new values in this expression, that step becomes summation from r is equal to infinity to r is equal to 1 by 3 raised to minus n. Minus n is r, and z raised to minus n, it becomes z raised to r. Then rewriting that summation from lower value to upper value. Lower value is r is equal to 1 to r is equal to infinity. Combining that power r, we get 1 by 3 into z whole raised to r, and that is nothing but summation from r is equal to 1 to infinity. That 1 by 3 into z we can rewrite as z by 3 and raised to r. Substituting the first value, we get r is equal to 1. We have the first term as z by 3. For r is equal to 2, we get z by 3 raised to 2. For r is equal to 3, we get z by 3 raised to 3, and so on. Taking z by 3 common from all this, remaining terms are, here it remains 1. Next one is z by 3. Next one is z by 3 whole square, and so on. This is z by 3 multiplied by sum of this term 1 plus x square and so on is 1 upon 1 minus z by 3. We get cross multiplying by 3, we get z by 3 as it is no change. It is 3 minus z upon 3, that 3 goes to numerator, and condition mod of z by 3 less than 1, and therefore 3 get cancelled. We get first z transform, or z transform for the first term as z divided by 3 minus z. We call this equation 2, and the condition is mod z less than 3. Then we try to determine the z transform for the second function. Z transform for the second term as summation of 1 by 3 raised to n, z raised to minus n changes from 0 to infinity. Combining this n, we get 1 by 3 z raised to minus 1 and whole raised to n changes from 0 to infinity. It is summation, transferring this z raised to minus 1 to denominator, we get 1 by 3 z and whole raised to n changes from 0 to infinity. Substituting the first value, n equal to 0, n number raised to 0, we get that one as 1. Next one is 1 by 3z whole raised to 1. Next, for n equal to 2, we get 1 by 3z whole square. Next, 1 by 3z cube, and so on. And once again, sum of this 1 plus x square plus x cube and so on is 1 upon 1 minus capital X. That capital X is here 1 by 3z. And the condition mod of 1 by 3z less than 1. Cross multiplying by z, we get 1 upon z minus 1 by 3 upon z, that goes to numerator, and therefore z minus 1 by 3. And the condition is, transferring this to other side, we get mod z greater than 1 by 3. This is second transform, z transform of the second function. and we call this as equation number 3. Then substituting these two values in equation 1, we get finally first z transform of the first term is z upon 3 minus z, condition mod z less than 3, and then z transform for the second term is z upon z minus 1 by 3, condition mod z greater than 1 by 3. Therefore, final answer is f bar of z is equal to z upon 3 minus z and plus z upon z minus 1 by 3. Condition, we combine these two inequalities, we get the first one as 1 by 3 less than mod z and this mod z less than 3. This is the region of convergence. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel and receive the notification for all such type of new videos. Press the bell icon. Thank you. Thanks for watching.